Hello everyone, this is Team Netizens. My name is Tejeshwar Singh and my teammates are Alka Kamble, Himanshu Malviya and Paras Mehta. First of all, we would like to thank SCNext for giving us the opportunity to present the case at such a high level. The presentation is basically divided into three main parts: problem identification, possible reasons and recommendations. To describe in brief, the main issues we identified were forecasting, process variability and inventory issues. The reasons for each of these were identified, like forecasting problem might be due to lack of communication between various departments, rapidly changing trends, or a wrong technique being used for forecasting. To improve this, we suggested various changes like using point of sales data and more inter-department communication. Similarly, process variability could be due to problems in machinery, raw materials or molds. To improve this, we need to check the raw material supply, upgrade machinery, and also implement Six Sigma and Lean technologies. Now the reasons for high inventory could be no discounts, process or changing trends. To improve this, we suggest putting outdated items on sale and using proper forecasting techniques. Now looking at the assumptions and the approach we followed to solve the case. First, the assumptions. Since SKU-wise forecasting and demand estimation is not available, we have assumed SKU-wise safety stock as per demand is not.
Hello, I'll be talking about errors due to forecasting. Now, the case mentions that only the business revenue level is forecasted by the sales department. Now, this information is of very little use to the production department. This leads to accumulation of SKUs which have less demand and scarcity of SKUs which have more demand. This is a major reason behind decreasing on-time in full metric. Inventory gets piled up, which increases overhead costs and capital gets locked up. To address all these issues, an SKU-based forecasting system must come into place. For this system, the point of sales data must be collected at the consumer level for each SKU. This data must in turn be matched with the distributor's demand. It will in turn reduce the error caused due to bullwhip effect. Apart from that, the advertising and sales promotion campaigns undertaken by the company must be included in their forecast. Implementing exponential smoothing technique will reduce the forecast errors gradually. Postponing lens differentiation as much as possible will avoid overstock and understocking. These methods will help in increasing on-time in full metric and decreasing the inventory. Next part will be taken by Himanshu.
The second big issue identified is process variability. Clearly, if the output is so inconsistent, the production department will never be able to produce the desired number of results, which will in turn increase inventory and overhead cost. The standard deviation in the output is pretty high. Hence, the CPK, the process capability index, becomes low as the standard deviation is inversely proportional to it, which can be seen in the formula. This low CPK indicates low process capability. This has a snowball effect on the whole system and in the end hurts the bottom line of the company. But this is just the tip of the iceberg as shown in the picture. The real problem lies below and needs to be addressed properly. Since detailed information regarding the process and enough data is not yet available, we have identified few possible reasons for the inconsistency in the process. Bad quality raw material. If the quality of raw material is not proper, it will affect the process directly. For example, the liquid monomer needs to be of proper viscosity throughout, and if it doesn't follow that, while spun casting to make lenses, the diopter will not be as desired. If the liquid is thicker, the diopter will be more, and if it's thinner, the diopter of the lens will less than what is required. Faulty machine. The machinery needs to work very accurately as the process is very sensitive. Example, if machine does not rotate exact RPM which is required, the thickness and diameter of lens will vary and we will not get the desired result. Next is incorrect process parameter. It may happen that parameters that are set are not accurate over the period of time due to several factors like wear and tear. It may happen that the process parameter do not suit the condition now. It may also happen that various errors have seeped in over the period of time. Now Now the question is how to address this issue, which is so ambiguous and there is no certainty about the root cause. Hence we suggest a 4-step process for this. First, collect data. First we need to understand where the actual problem is. Hence we suggest to collect data from each process point for a constant period of time. Thus a separate team must be formed to collect data, measuring various parameters at various stages in the process routing, and also record the process parameter fed to the system. Now we have the data. The next step is to analyze it. We need to find out the individual points where the error is induced in the system by comparing the data against the standard to find the problem areas. After this, we need to check the source of it by checking the fitness of machine, specification and parameter, etc. Then the mapping of the problem areas would be done. After this, the next step is to improve. After the problem areas are mapped, we need to improve the process by making necessary amendments to address the problem. This stage is extremely necessary and important too. The company should look for improvements which would last long term rather than choosing a short term solution. Example uh, Example of improvement can be, in the case the problem is there with raw material, we need to change the supplier or put in place a quality management system at vendor location. The company at this stage should also induce Lean and Six Sigma methodology and make it as a culture of the whole system. The final step would be keep a check on the process. Any process, if left on its own after doing some changes, would most probably revert to its initial stage, and all the improvements done will be negated. Hence, company needs to standardize changes and keep a proper check on it. Also, employee training is crucial to make the improvements effective on a long-term basis. Now the question is how to address this issue, which is so ambiguous and there is no certainty about the root cause. Hence, we suggest a four-step process for this. First, collect data. First, we need to understand where the actual problem is. Hence, we suggest to collect data from each process point for a constant period of time. Thus, a separate team must be formed to collect data, measuring various parameters at various stages in the process routing, and also record the process parameter fed to the system. Now we have the data. The next step is to analyze it. We need to find out the individual points where the error is induced in the system by comparing the data against the standard to find the problem areas. After this, we need to check the source of it by checking the fitness of machine, specification and parameter, etc. Then the mapping of the problem areas would be done. After this, the next step is to improve. After the problem areas are mapped, we need to improve the process by making necessary amendments to address the problem. This stage is extremely necessary and important too. The company should look for improvements which would last long term rather than choosing a short term solution. Example uh, Example of improvement can be, in the case the problem is there with raw material.
One of the issues that we identified is high inventory. Some of the reasons for this is that finance team is denying to sell the inventory at a standard cost. This standard cost includes cost of production and other expenses. In this case, cost of overhead is 70%. That means if the lens is of rupees 100, then its cost of production is 30 and other expenses like its storage, advertisement and legal fees comprises of rupees 70. By generally accepted accounting principle, if lens are sold below rupees 100, losses are incurred in the books. The other reason is that the range of the lenses coming out of the batch seems to be getting wider. That means suppose we need 100 units of raw material to make 100 units of minus 3 diopter lenses. However, the output is 85 units of minus 3 diopter lenses and rest 15 units are varied in the range from minus 2.5 to minus 4 diopter. This eats a loss of storage space and it incurs the cost. Again, there is a huge variation in demand of the SKUs. What is in demand today may get outdated after some time. So the stock of outdated inventory just gets piled up. And because of the same reason, we can say that safety stock calculation of SKU is unreliable. All these issues will ultimately lead to high inventory. To reduce this inventory pileup, there are some of the measures like putting outdated lenses on sale, calculate safety stock of parent part SKU wise, categorize high and low revenue products. So by putting outdated lenses on sale, we can we can it will help to reduce the stock of not in demand lenses and also reduce overhead cost incurs. Again, next, by adopting continuous replenishment method, the parent parts will be manufactured based on the demand of the SKUs and this will in-house reduce the inventory pileup. The next and the most important is it by categorizing high and low revenue products, we can we can apply a Pareto's ABC analysis to determine high revenue and low revenue products. It will help us focus on the high demand product specifications. All these measures will ultimately help in better inventory management. Next, The production department is worried about inventory pileup and asks sale department to put it on sale. However, finance department doesn't allow to sell it below the standard cost. On the other hand, sales department claims that their forecast to be 95% accurate. But the thing is, their forecast is revenue based, which is not that much help to the production department. With all these examples, we can say that there are internal department conflicts in the organization, which is in a way difficult for the cross-functional team to convey their decisions. So there are some measures to sort out these interdepartmental issues. First is leveraging Class A status of ERP system. Other is collaborative awareness, and next is goal congruence. It is claimed that ERP system of organization is accredited with Class A status. So the same can be used to integrate different departments of the organization. It can help to standardize the internal data procedure system so that different departments are on the same line for information sharing. Next is the collaborative awareness. It can be said as an inter-organizational understanding. It looks at trusting long-term relationship with the supplier. This can help alleviate the possible reason of bad quality raw material supply. Next is the goal congruence. It means instead of pursuing their own objectives, cross-functional teams should align their goal in terms of organization as a whole. And organization cross-functional training may help the department in understanding each other's perspective. So with all these solutions, I thank you SCNext for giving us this wonderful opportunity to present on the international platform. Thank you. Thanks a lot.